In section 10, topic 4, we're multiplying and factoring monomials. So the first two examples that I'm going to be looking at are going to be multiplying a monomial to some polynomial, and then the second two examples are going to be factoring monomials. Now we did do this in the regular school year, but we're kind of combining it all together. So we're going to use our exponent properties when we're multiplying and distributing. And same thing, we're going to use our division exponent properties when we are factoring. So what we're going to do is, to get rid of parentheses, we need to distribute. So I'm distributing and I'm multiplying. So remember, when you multiply, the exponents are added together. So on the outside of this problem, I have negative x to the first power. So negative times a negative is a positive 4x, and we're adding the exponents. 1 plus 3 would give us 4. Now we're distributing the negative x to the first power to 8x squared. So we're multiplying negative 1 times 8 is negative 8x, and we need to add the exponents. The first power plus the second power is the third power. For the second problem, we're going to do the same thing, where we're going to take this number on the outside, this monomial on the outside of the problem, and we're going to distribute to all three numbers inside the parentheses. So when we do this, we're going to multiply the coefficients. 6 times 7 is 42. And then we have x, and then we need to add the exponents again. So we have 2x's plus 2x's would be to the fourth power. So I distribute again. I distribute to that 3x term. So 6 times 3 gives us 18x. And how many x's do we have? We're adding them. So we have 2 plus this 1x out here. So 2 plus 1 would give us 3. And lastly, I distribute 6x squared out to this negative 2. So I'm multiplying the bases. 6 times 2 is negative 12x. Since there aren't any x's over here, we're just adding 2 plus 0 x's. So we would just have x squared. So when we're factoring, we're going to be using the greatest common factor. So that means that we're going to use the biggest number, the greatest factor that goes into all the terms, but we're also going to take out the smallest exponent. So really our problems, they're starting like the answers to the ones that we just solved, and they're going to end up looking like the start of these problems. So like this, the greatest common factor for all three of those would have been 6. So I pulled out a 6, and the smallest exponent is 2 at the end. So I pulled out this x squared. So what we're really doing is we're taking the answers to the problems that we just did, and we're working backwards. So since we're factoring using the greatest common factor, first thing we need to do is find the number that goes into all three of these terms. So the number that goes into 20, 15, and 40, the biggest one, is 5. And then for the exponents for the variables, we're just going to use the smallest exponent. So the smallest exponent between 6, 4, and 2 would be this x squared. So we've done this before, where we're going to divide everything by 5x squared. So 20 divided by 5, well, so what we're doing is we're taking out this 5x squared. And what will be left when we divide is what we're really doing. So 20 divided by 5 would give us 4. When we have x to the 6th divided by x squared, remember we're subtracting the exponents. So 6 minus 2 would give us x to the 4th minus 15 divided by 5 is 3x. Again, we're subtracting the exponents. 4 minus 2 gives us 2, plus 40 divided by 5 is 8. And I have 2 minus 2 which would give me 0. So there's no x's after the 8. 0 x's after the 8. And our last problem, we're doing the same thing. We have 6x to the third plus 8x squared minus 4x. We need to take out the greatest common factor. So the biggest number that goes into 6, 8, and 4 is 2. And then again, we're using the property, we're using the smallest exponent. So we have 3 x's, 2 x's, and 1 x here. So that the smallest exponent would just be x to the first. So we need to factor out a 2x from all 3 of these terms. That means that we're dividing. So factoring out the 2x means we're dividing everything by 2x. So 6 divided by 2 is 3x. And remember, we're subtracting the exponent. So I have 3 minus this 1x on the bottom. So 3 minus 1 would leave me with 2 plus 8 divided by 2 is 4x, and I'm subtracting the exponents. 2 minus 1 will just leave me with 1. So I don't need to put a 1 here. It's not necessary because we know we just have 1x after the 4. So then we have minus 4 divided by 2 is 2, and then 1 minus 1 on the x's would leave me with 0 x's. So there's no x's after the 2.